Okay, I believe this is attempt 4, looking at making this recording, going over some of these problems. So let's see if I can get it this time. Which statement completes step 5 of the proof? So the first thing to do is look and see, well, what are we trying to prove? And it's the product of the slopes of jk and j prime k is -1. Therefore, lines F and G are perpendicular. So notice that JK and J prime K, so those do look perpendicular, and JK is on line F and J prime K is on line G. So when we have perpendicular lines, their slopes, when you multiply them together, equal -1. So that's what we're going for here. So first, KL, line segment KL, is parallel to the y-axis. So there's KL, here's the y-axis. Yeah, it's right on top of the y-axis. And JL is parallel to the x-axis. Yep. Triangle JKL was rotated 90 degrees clockwise to create triangle J prime KL prime. Yep, I can see that it was rotated. But point K didn't change position, so it remains point K. And because all we did was a rotation, those two triangles are congruent. All right, so far so good. KL prime is perpendicular to the y-axis. Yep, I see that. And J prime L prime is perpendicular to the x-axis. Yep, I see that too. JK lies on line F and has slope of 3. And remember, slope is equal to change in y over change in x. And this is read delta y over delta x. Those are Greek letters. They just mean change. Delta means change. And it says that it's 3, which is 3 over 1. And what I can see is that from J to K, as we move from left to right, we go up 3, that's our delta y, to the right 1, that's our delta x. So delta y is 3, delta x is 1, which equals 3. Okay, good so far. So this line segment has a slope of 3. Now, what we're wanting to show is that this line segment and this line segment intersect at a 90-degree angle. That means that their slopes, when we multiply them together, is -1. Well, I know that 3 over 1 times some other fraction, so something over something, is equal to, and in this case, the answer is, it's -1. Well, the only way to get -1 is if when we multiply across the top and across the bottom, we get the same thing. So in this case, we know that this has to be negative, because a positive times a negative is a negative, and it's got to be 1 over 3. And that is the way slopes of reciprocal lines work. They're called opposite reciprocals. So this is positive, this is negative, so they're opposites. And reciprocal, the fraction flips upside down. So this 3 moves to the bottom, and this 1 moves to the top. So they are opposite reciprocals, and their product, the result of the multiplication, is -1. So this has a slope of -1, that's the delta y right here, over delta x equals 3, because we go to the right 1, 2, 3. So let's look down here. Oh yeah, so all of them talk about having a slope of -1/3, so that doesn't help. But what is the line that we're interested in? We're interested in this J prime K right here. J prime K, which is this one right there. All right. Number 5. What is the y-intercept of the line perpendicular to that line? That includes the point 31. So this is in slope-intercept form, and we know that the line that is perpendicular to this one is going to have a slope that is an opposite reciprocal. Opposite, this one is positive, so we need a negative. Reciprocal, 3 over 4 becomes 4 over 3, multiplied by x plus b. Now b is our y-intercept, and that's what we're looking for. So we need to find b. We're given this point 3, 1 that is on the line that we're looking for. So we're going to make our x value 3 and our y value 1. So our x value 3 and our y value 1. So we have 1 is equal to negative 4/3 times, times 3 plus b. Now negative 4/3 times 3, well, those 3's cancel and make a 1. So we have 1 is equal to, negative 4 is what was left there, negative 4 over 1, so negative 4 plus b. Now we can add 4 to each side, and we will get 5 is equal to b, and therefore our answer is right there. That's our slope, or excuse me, our y-intercept. All right, so number 6 here. Which statement explains how the lines are related? Well, if they're both in the slope-intercept form, that's going to be easier. So what I'm going to do is I'm going to take this one that's written in standard form, and I'm going to subtract x from both sides, and I will get y equals negative 1x plus 2, because when I subtracted x here, it's the same as subtracting 1x. And similarly, there is a 1 here. And hey, look, their slopes, 1 and negative 1, they're opposites because this one's positive, this one's negative, so they're opposites. And they're reciprocal because 1 is equal to 1 over 1, and when you flip it upside down, it's its own reciprocal. So they're opposite reciprocals, they're slopes, and that means their lines are perpendicular. Number 8, this is a super complicated problem, not even going to lie to you. Rectangle TUVW is on a coordinate plane at, and then it gives these 4 points, TUVW, and they're kind of complicated. We don't know where they are, but we know how they relate to each other. What is the slope of the line that is parallel to the line that contains TU? So basically what we're asking is, what is the slope of line that connects those 2 points? And remember that slope, don't forget, slope is delta y over delta x. Delta y, change in y, as we go from this y value to that y value, we're simply adding 2. So our delta y is 2. As we go from our x value here to that x value, we're adding 2. So our delta x is 2. And that's a slope of 1 because 2 divided by 2 is 1. So TU, that line segment, has a slope of 1. So any line that's parallel to that line will also have a slope of 1. That's the simplest, most straightforward way to answer that question, but conceptually it's not easy. Number 10, which statement explains the relationship of sides BA and B'A' after the rectangle has been rotated 90 degrees counterclockwise? So I think the easiest thing to do is to look at our 2 points, B and A. B is the point 1, 3. A is the point 3, 5. Now when we rotate a point counterclockwise 90 degrees, what happens is the x value and the y value switch places, and the y becomes the negative x value. So what I mean by this is this. B prime is going to go to right there, and it's going to be -3, +1. So notice that the y value moves into the x value's position and changes signs, and the x value just moves into the y value's position. So similarly, A is going to move into -5, +3. That's A prime. It's going to be -5, +3 because it follows that same pattern. The y value becomes the x value but changes signs, and the x value becomes the y value. And so now what we can notice is that I'm going to change the color on these. Sorry about that. We're going to make them red. So if we look at the slope of A prime, B prime, the slope, delta y over delta x, if we go from the y value here to the y value there, we subtract 2. So it's -2 for the delta y. If we go from the x value here to the x value there, we add 2. So the delta x is +2. -2 divided by 2 is -1. Similarly, if we go from the, let's remind ourselves that slope is equal to delta y over delta x. If we go from the delta y here to the delta y there, we subtract 2. And if we go from the delta x here to the delta x there, we subtract 2. -2 divided by -2 is +1. We could have gone from y to y and gotten 2 over x to x and gotten 2. 2 over 2 also equals 1. It doesn't matter which direction we go as long as we start with the same point to determine our delta y and our delta x. So here we have a slope of 1, here we have a slope of -1. Those are opposite reciprocals. That means their line segments are perpendicular. And so B prime, A prime has a slope of -1 and is not parallel, it's perpendicular to BA. So our answer is this one right here. Now, these questions rely a lot on Algebra 1 skills, so makes it tough. I hope that this helps, and good luck in the rest of the lessons and class.